Okay, this was the last one that I was asked to do. And this one is another special points problem. In this particular case, there's only two special points, A and B. And I'm going to do and it's 2 degrees of freedom. That's why I'm given two velocities and 2 accelerations, right? I'm told that the collar moves with the speed of 5 and a constant rate of increase relative to the hoop, and then I'm also given the angular velocity and angular acceleration. Okay, so here we go. I'm going to use special points. There's A and there's B. So let's do the velocities first. So velocity of B equals the velocity of A plus omega of the body that they're sharing together, which is the hoop. I'm going to call it a hoop, cross R, and the R is going to go from A to B, plus V rel. Okay, let's plug what we know in here. So the velocity of B equals velocity of A. Well, A is in permanent contact with the ground, so that velocity is 0. Omega of the hoop is given to be, looks like a -6 because it's clockwise, so it'll be a minus 6k cross R from A to B. Looks like it goes down, so I'm going to do my typical I is to the right, J is up, and K is out, right-handed, just like normal. So the R is equal to 0.4 or 400, whatever, oh no, I guess it's 450 actually. So it'll be 0.45. And it goes down, which would be in the minus J direction, plus a V rel. Okay, so now you pretend like you're standing here. And so you don't see the hoop moving. The only thing that you see is the collar B is moving. It looks like it's going to go clockwise to me. And they say that it has a speed of 5. So I'd say, okay, well, then I see it going a distance 5. In what direction is it headed? Oh, it's headed to the left. So this would be a minus 5J. Let me rewrite that. Okay, so this would be plus V rel. That V rel is a negative 5, it's going left. Oh, golly, man. Let me erase this. Boom, erase this. Let's just get rid of that guy. Okay. So it's minus 5, and it's going in that direction right there. It's moving this way, which is negative I. Right? So let me fix that. Let me fix that. Oops. Pick up the eraser. There we go. And so there is omega cross R. The V rel is a minus 5 I. It's going a speed of 5, and it's going to the left. That's what it looks like to me that it's doing. Okay. So let's punch this out. So the velocity of B is equal to, I'm going to bring the, want to do the cross products, I'm going to bring the negatives out with the number. So this is going to be 6 times 0.45, whatever that is, positive, and then K cross J is going to give me a negative I, minus I. So I do the cross product, and then I have another minus 5I. So the answer is whatever 6 times 0.45 is. So it's going to be a minus 6 times 0.45 minus 5. All of that is in the J. Okay, so the velocity of B in the X, velocity of B, oh, I'm sorry, that's not J, that's an I. So the velocity of B in the X is equal to whatever this number is, the velocity of B in the Y. There's VBY on the left. On the right-hand side, nothing. I don't have any J's. 0. And if you look at it, you say, yeah, that's about what it looks like it's doing. So no problem. Okay. Now, how do you find the acceleration? You mimic the velocities. So here we go. We're going to mimic the velocity. So I have the acceleration of b equals the acceleration of a plus alpha of the hoop cross r from a to b minus omega squared of the hoop times RAB plus 2 omega hoop cross VREL. The VREL I had up here. This was the VREL. Right there, minus 5. Minus 5I plus AREL. Okay, so here we go. What is a rel? Well, you're looking at it right here. Does the red hoop look like it's moving to you? No, it's a picture on a piece of paper, right? So no, the red hoop's not moving. That's that's the relative, right? You're standing on the red hoop. You're not seeing anything move. Well, then what does it look like B is doing? Well, it looks like B, to me, is moving on a circle. That's what it looks like it's doing. It's moving on a circle with a radius of curvature of 200 millimeters. Do you remember what the acceleration is for something moving on a circle with a constant? Yeah, I remember that. That was the tangent normal stuff. So the AREL term, I'm thinking back to chapter 12. Oh, that's the tangent normal. What's the tangent acceleration of something on a circle? It's equal to the speed change. Well, they told me the speed change is 1.5. So the speed change is 1.5. It's getting faster, if I'm not mistaken. Let me look at it. What does it say? Relative hoop. While the hoop rotates, angular velocity. Hang on just a second. Okay, I'm not exactly sure where I was. Okay, so we had the relative. Okay, the relative is you're looking at it. You don't see that the hoop is rotating because you're standing on the hoop. You don't see that. So it looks like the guy has got a moving on a circle, and so you have the easiest thing I can think of is tangent normal. It says it's increasing its speed, so that means it has a V dot, which is 1.5, and it's going to be directed to the left. So this is 1.5 in the negative I direction. That's the V dot. The normal component of acceleration is speed squared divided by radius of curvature. So speed is 5. So speed squared is 25. Divided by the radius of curvature, I'm using meters here, so that would be divided by 0.2. That's the radius of curvature. V squared over rho. And the direction, well, it's going to be always inward to the path. Well, inward is this direction right here, which is the positive j. So this would be plus j. Okay. All right, so I guess I've got, a little confused here. Okay, so anyway, what I'm going to do then is I'm going to put this stuff, which is the relative acceleration, into here. And how many unknowns? Well, the acceleration of A, that's 0 because he's permanent contact with the ground. The alpha of the hoop is given. That is equal to, looks like a minus 3K. That's the alpha of the hoop. The R, I've got that. That was up here. Right there. This is the R, same R as it was before. Omega of the hoop, I've got that. That was 6. So basically I've got everything that I need here. The only thing that's unknown is the acceleration of B in the X and the acceleration of B in the Y. So I just plug and chug. We'll go ahead and do that. Might as well. So let's see. The acceleration of B equals minus 3. Let's see. What is R? R is equal to 0.45 J. Minus 0.45 J. Okay. So let me put some numbers in. Minus 3K cross. This is from A to B. That is a minus 0.45 J minus 0.45 J plus, let's see, minus omega. Omega is 6, so omega squared is 36. The R is a minus 0.45 J Let's see, then this is, I'm going to take out the 2, the omega hoop, and the 5. So that's 2 times 6 is 12, times 5 is 60. 60, and it's the omega of the hoop is minus, so minus is plus, and then k cross I is positive j, so this would be a plus j. Maybe I screwed up in my head a little bit. And then let's see, I've got the a rel, and the a rel is a minus 1.5 I plus looks like a 12, I don't know what it is, it's 25 over 0.2 j. So now you know, let's do the cross product here. Minus 3 times 0.45 is 3 times 0.45. K cross j is minus I, so this ends up being a negative I. And then let's see, minus is plus. 36 times 0.45 j plus 60j minus 1.5 I plus 25 over 0.2 j. You just add up your j's, add up your i's, boom, and you got the acceleration of b. Okay, so that's that, and I think that was the last one you asked me to do, and so we're done.